All right, let's talk about another interesting topic within statistics. And within that, we're talking about absolute measure of variability. And today we're going to discuss something called as mean deviation or mean absolute deviation. It can be abbreviated as MD for mean deviation, or it can be also abbreviated as MAD, MAD, mid absolute deviation. And it goes by different names, but we'll come to that later in the point. And I've just got this visual from the earlier episodes for a reference standpoint of view. What we have covered so far is we have covered this and we have covered this on the relative side. In this episode, we are going to talk about this. And I was just checking the syllabus from an exam standpoint of view for the Maharashtra State Board for first year diploma. I don't think they have this for the corresponding relative measure for the mean deviation, which is the coefficient of mean deviation. So we don't have this. So we have this in syllabus, we have this in syllabus, and we directly have this. So we don't have to do this. That's a good news. Okay. All right. So let's get started. And I'm going to just take an example and run through the example, and eventually we'll kind of compute what is mean deviation as opposed to just talking about mean deviation and why we need that. Okay. And what we need to have as a prerequisite is how we calculate mean in general from the first few episodes, and maybe group data for some of the exam problems on how we solve that. So these are the two things you would need: how to calculate mean and what is the mean for a group data. How do you do that using the midpoint formula? In case you don't recall that, it would be a good time to refresh from the first episodes or the first two episodes on calculating mean. Okay, let's take an example and get started. Assume that we are going to have few values in the data set, and this is actually an exam problem that has come real. So I've taken this problem, but eventually when I solve the paper, I'll tell you which problem it was, and then you can correlate to this if you need any further explanation. But for now, let's assume that we have got 8 random values, and these values are nothing but the distances traveled from a particular point. You can assume either you as an individual traveled all these distances from a particular point, or you traveled it over a period of 8 days, or 8 different people traveled it. But assume that these are 8 distances in general that you have got. Okay. And let's call these individual values as X. Okay. All right. And what I've done is the visual helps. So I'm going to also put the visual. So what I've done is I've taken a simple number line and I've plotted all the values that you see here, 3, 6, 5. I've circled them in kind of blue color. So that those are our values of X, or the different distances that we have traveled. Okay. And this, the next step is more important. Even in the exam, you don't have to do this piece, the number line piece, because that's just for explanation. But in exam, you'll have to do this piece to put the values in the table, because it's very easy, and you will not lose track of what you're calculating, because you'll have to jump from one step to another, and there are 4 or 5 steps before you calculate the final answer. So it would be a good habit for you guys to tabulate all the values or put it in a table. Okay, so this is important from an exam standpoint of view. So you will follow this in the exam, and these visuals are just for references. Okay, so don't worry about exam. So what I've done is I've plotted the values on the number line, as well as I plotted the values in a tabular format. So what I've done is I've taken all these values. We have got 8 values if you count here. If you see here, 1, 2, 3, 4, 5, 6, 7, and 8. So we have got 8 values: 1, 2, 3, 4, 5, 6, 7, and 8. And I plotted all the 8 values as per the given data set. Okay, this is the data set. I plotted this. So you see here, these are my given values, and these are my 8 values total given. So total value n is equal to 8. Okay, over here n is equal to 8, and these are the different distances that we have traveled, which we are calling it X for now. Okay. All right. If I ask you a question on this, just on this so far, what is the average distance that we have traveled, or we have traveled on any day, or this put together? If there are 8 different people who have traveled, what is the average distance we have traveled? What is the mean? And we know that how to calculate the mean. We are going to add up all these values over here and divide it by 8. All these values added sum to 76. So we are going to do that in the same fashion. If you see, how to calculate the mean or the average distance traveled, we are going to add up all the values in the numerator and divide it by 8, the number of values in the denominator, or the frequency that we can call, and we get a value of 9.5. And mean can be represented using both these notations, x bar or mu. I'll not get into the details on what to use when, because that's out of syllabus, but typically textbooks use this x bar. You can use x bar for the most of it, or you can use mu, it doesn't matter. So let's so what we have got so far is the average distance traveled, put all these distances together, is roughly 9.5. Okay, whether it's kilometer or whatever the units, they are not given the units. I'm just trying to add the example. In the exam also, you may not get distances, they might just give you this data set and say calculate the mean deviation, but I'm just trying to add a flavor to this example. And if you think in terms of distances, understanding mean deviation is very easy. Okay, so assume that on average all these guys traveled on an average distance of 9.5 kilometers or whatever is the unit. Okay, so now we have got 9.5 as a first step. I'm going to take this 9.5 and I'm going to keep on overlaying on this number line, and then also populate this table. So I'm going to use both these visuals and keep on upgrading them. Okay, so what I've done is I've taken the number line over here and I've exactly pinpointed where this 9.5 is, between 9 and 10. I'm calling it average is equal to mean is equal to 9.5, the value of x bar or mu. Likewise, I'm also populating the table. So these two columns we had from the previous step. Now I'm also adding a third column and I'm just putting the value 9.5 across the board for all of them, because 9.5 is the value that we got as an average or the mean distance. Okay, now let's say if I ask you a question over here, if you see, okay, if I ask you a question, how far are all these 8 distances or 8 values that you have got, these 8 values that I'm talking about here, okay, how far are these distances from the mean distance, that is from this distance? So what is the difference between this, what is the difference between this and this, what is the difference between this and this? That's the question I'm asking. Or in other words, I can say, how deviated are these 8 values from the mean distance? So what is the deviation between this individual 8 values from this mean? What are the individual deviations? That also we can say. Okay, and the way we calculate that is very simple. We take the values in the x, the 8 values one by one. These are the 8 values that we have, or we can see in this column. So the 8 values that we have, we'll take it one by one and subtract or take the difference of these values and the mean distance, which is 9.5. That is what it's mentioned here. If you see, x minus mu, or you can also call it as x minus x bar, which is the mean distance. Okay, that's what we're going to do. So that will tell us what are the individual deviations or what are the individual differences between each of this distance traveled from the mean. Okay, and let's see, let's plot that on a number line as well as on a graph. So if you take this number line over here, now we had this 9.5 earlier, we had this blue circles for the 8 values, and what I'm trying to do is I'm taking each of this blue circle. I want to know how far each of this blue circle from the mean. Okay, that's what I want to know. So x minus the mu or x minus the x bar. So this value is the mu or x bar, and each of these circles over here is x, the value of x. We have got like that 8 values, right? So we are going to get x minus the x bar or x minus the mu, and we are going to calculate that. For example, if you see, this value of x is 3, so 3 minus 9.5 is the first value, and the value is negative 6.5. Like that, we are going to calculate. If you see this red arrow marks, that shows the individual deviations or the individual distance of each of this value or the distance from the mean distance. That's what we have got. On the left side, if you see, we have got all values in negative because x is going to be smaller than the average. On the right side, if you see, all the values are positive because the value of x is going to be greater than the average distance. For example, if you see here, 18 is the value of x, so 18 minus 9.5. Okay, that's what we are getting. So we get value of 8.5. Okay, that's what we are getting. So that's what we get here. So now we have plotted this. Okay, and what I'm going to do is, like always, I'm going to also populate the table to add this distance, and this will be clear while we do that from an exam standpoint of view while solving the problem. So the first 3 columns over here until this part was already there from the previous few steps. Now I've calculated the difference between each of this value and the average mean distance, and I've got these values. And likewise, if you see, some of the values are negative and some of the values are positive. So whatever is on the left of the mean is negative, and whatever is on the right of the mean in terms of the difference is positive, right? That's what we're getting. So we have populated this number line, and we also populated the table. Okay, now let's keep going. Okay, now the question I'm asking is, okay, now you have got the individual deviations. We got these individual deviations. That's a great thing. But the question I'm asking is, I don't want the individual deviation. Tell me on an average, all these values put together, if you see all these values put together, what will be the mean deviation? What will be the average mean deviation? I don't want the individual deviation. I want the average mean deviations for all of this. And what we will do in that case, if you see this question, as a whole, all deviation values put together, what is the overall average deviation from the mean? In other words, what would be that one measure that denotes the overall average deviation? In a way, we're calculating the mean of a mean, right? Because we already have this mean over here, and now we have the individual deviations. Now we are trying to calculate the mean of this overall deviation. That means we're trying to calculate the mean of a kind of a mean kind of a thing. Okay, that's what we are trying to do. And what this will tell us, like in essence, why it is required, it will tell us on an average, what is the distance between any value from the mean value. If you see the distance between any value over here, each one is a different value, right? Each one has a different value. And I don't want each one as a different value. I want to know what is that one value. If I average out, that will tell me that on an average, each of these given values is at the most the same distance from this number line. Just how we calculate mean. If you see, we have calculated just one number. It tells what is the average score, right? That's what it means. Similarly, what is that one value? Instead of giving me individual deviations for 8 people, tell me on an average, what will be the average deviation from the mean for all of this put together? That's what I am asking, okay? So mean of a mean kind of a thing. So to get that, we will have to add all these values, right? Because that's how we do. We add and then divide it by the frequency, which is 8 here, right? We want to add these values. But let's see if we can do that, okay? All right, let me get this out. Okay, let me see if I add this. So if I add all these values, see, I've just calculated this in Excel and put, if I add all these values, the net value I get is 0, okay? And that's a problem, because if I get a 0, anything divided by 0, if I divide it by frequency 8, it's going to be still 0. That's not going to work. So we have a problem, right? So I know I need to add all the individual deviations to get the average. But if I add, I'm getting the value of 0. And why do we get the value of 0? Is very simple, because what we have is from this diagram, if you see, if I just remove all this, hold on, let me just remove all this doodles. So if you see this diagram, since the average line is 9.5 in the middle, that means we are getting an average distance of 9.5, which is right in the middle. So that implies that all the other values that we have, half of the values will be on this side, 50% of the values will be on one side, and 50% values will be on the other side, right? In terms of the sum of this. And because of this, half of the values, the sum of half of the values is going to be negative, and the sum of the remaining values will be positive. And exactly this average is in the middle. So this negative in essence cancels out the positive, and that's what is happening here, right? Because it's not going to work out that way. If you calculate this, if you add up all these things like this, it's going to be 0, because your mean is in the between, and your values are split across that. So the average is going to be negative if you take this, okay? And that's why you're getting the value -0 here. But if we still want to find the average mean, but we cannot go with this approach because it's showing a negative, it's going a 0 value. So what are the alternatives? There are one or two ways to do that. The first value, one approach we'll see in this, in the mean deviation, and others we will see it when we do the standard deviation and the variation. When we come to this part, we will see that there is a better way to do that and not the mean deviation, but we'll come to that later. But let's check out one of the possible ways to do that. And while I say this, you might be already blinking. That's what are different ways to get rid of the negative. There are two ways to get rid of the negative. The first way is simply take the absolute value, which is just ignore the negative sign and take the absolute or the modulus of that, right? That's what we do here. So what is the absolute value? We just ignore all the negative signs and we just take the absolute value. If you remember, if minus 5 is a value, the absolute value of minus 5 is 5, because absolute value is just taking the positive sign, just the magnitude of that. We don't need the direction or the positive negative on that one. So if I take the absolute values, I'm saying, one of the possible solution is, if I just take the absolute value, we are just going to take only the positive values, right? We are going to ignore the negative values. So all the negative sign is gone. If you see, whatever was this whole region was negative, right? Because of the differences. Now none of the values are negative. All the differences are gone. I'm just going to keep the value positive, okay? And now I have all positive values, and I'm going to again populate my table. So if you see here, from here I moved positive value. So this was my x minus mu or x minus x bar, which was the actual value with negative and positive signs, which was netting to 0. But now what I've done is, for each of this row, I'm just taking an absolute value. If you see this 2 bars in red color, they're absolute values. So that means I'm just going to ignore the negative sign and make sure all the values are positive. The positive will remain positive. The negative will also become positive. If you see here, minus 6.5 is becoming 6.5, minus 3.5 is becoming 3.5. And once I get this, and if I add this now, I'm getting a value of 34. Okay, that means now it is no more 0. I'm getting a good value of 34. So now I'm going to continue with my journey on calculating the overall average mean deviation or absolute mean deviation, because I've taken the absolute values. And that is very simple now, because you have the number over here, and I just need to divide it by the frequency or the number of given values, which was 8, like we would have done for the mean. So if you see here, I'm taking all these values over here, which is the last column, 6.5, and all these highlighted things I'm going to add. That's what I'm going to do here, over here, and divided by the frequency 8. So that gives me 34 by 8, 4.25. And what is this? This is called as a mean deviation, the overall mean deviation. So the overall mean deviation is, I'll explain this formula in a while, but this is what we have done. The overall mean deviation for this whole problem or problem set is 34 by 8 is equal to 4.25. And it's also called by different names. It's called as mean deviation. It's called as average mean deviation, because it's the average of all the individual mean deviations. It's also called as absolute mean deviation, because we are taking the absolute value of that, we are ignoring the negative values. And it's also called as mean deviation with respect to the mean, because we are calculating the mean deviation with respect to the mean. So this is also called as this. In the exam, mostly they'll be asking you this phrase, calculate the mean deviation from mean. This is what they will ask. But in case they ask you any of this other equally valid terminologies or jargons, you can still calculate the same way. So it's called as MD, or average mean deviation, or absolute deviation, MAD, absolute mean deviation, or mean deviation from mean. All are the same. Okay, and the formula for that is whatever we have done in this tabular format. Now you know why we did this in tabular format, because if I directly start with this formula over here, and if I would have started the episode with this, it would be very dry and confusing. Now we know what is this formula stands for, how did it come. For example, what we're trying to do is we're calculating the mean absolute deviation, or MD. That means there is an absolute value, and this particular absolute symbol indicates that's the absolute part. And since we're talking about deviation from the mean, this x minus mu that we calculated in this table here, x minus mu, what is the individual deviation from the mean of these two values, that what it indicates. And then we converted that into the absolute value over here, and that's what the absolute kind of part means. So we know why we need x minus mu or x minus x bar. Now we know why we need the absolute value. Then what we did is we added all of them. We did a summation of all of them, and that's how we got this number 34. If we added all of this, right? That's how we got 34. And finally we divided it by the total number of given values, or the frequency, which is n, which is this n over here. If you see here, n over here and n over here, and that's how we got the final answer as 4.25 as a final answer. So this is the formula. I think in the exam, if you forget, it's fine, you can write it, but if you don't remember, you can just remember the steps on how to calculate it, and that way you can formulate the formula on the fly. For example, we are going to calculate the regular mean first, then we are going to calculate, this table will help you. All these 5 steps I have put here, right? All these 5 steps are nothing but the steps over here. Step 1, step 2, step 3 and step 4. First is write those given problem in the tabular format as it is over here. This was given to us. Okay, the step 1 is calculate the average mean distance the regular way. Just add them all and divide by the frequency, which is what we did here. The step 2 is calculate the individual deviation or distance from the mean. That means subtract x minus mu or x minus x bar, which is what this is. Then we don't want negative values because it will sum to 0. So the step 3 is take the positive side of that, ignore the negative sign. That's very easy. Simply remove the negative sign and we get step 3. And step 4 and step 5 is add up all these values that we get here and again divide by the frequency. It's the same thing that you did in step 1 to get the average distance. We're going to do the same thing. The only thing is in this time the numerator is going to be all the mean deviations that we see here and divide by the frequency. Those are the 5 steps. So remember the 5 steps, and this is what I put as the 5 steps to solve the problem. But if you put in a tabular format, it's very easy. You will not forget and you will not kind of miss also. And that's how we kind of calculate the mean deviation and stuff like that. There are few good reads that I borrowed. One is this link from Statistics by Jim. That's a very good link. And interestingly, if you are curious why we need to even kind of do this, what's the problem with mean deviation, he has put some examples of why we need that. For example, we cannot just do mean. For example, what he has done is he has taken these 2 examples. I'll not go into the details, you can refer this. What he has done is he has taken 4 points over here in one data set, and again different 4 points over here, another data set. Okay, completely 2 different data sets with 2 different data points. But the beauty is the mean, the regular mean or the arithmetic mean for both of them is same, because if you add and this thing, it will be the same. Okay, which is I think 10 over here, the average of 10. If you add all these numbers and divide by 4, it will be 10. For example, 2 plus 1 plus 1 plus 2, it will be kind of 8 plus 9 plus 11 plus 12. If you say that the arithmetic mean is 10, so if both the data sets, although they have different sets of values, if both the data sets have a mean of arithmetic mean of 10, then does it mean both are same? No, because if you see the spread here, the values are very spread. This is the bigger spread, and these are all smaller spreads clustered in a region. And hence we need to understand we cannot compare this data set with this data set because the spread is different. So the regular mean may not work, and hence we need to have a mean absolute deviation where we compare on an average whatever is the mean, how far is each of these points, although the mean is 10 for both of them, how far are these individual points in blue away from this, that is the x minus x bar that we understood this thing. And this part, this red bar kind of shows the distance. So if you see in the second data set, the deviation or the individual deviation is more, it's more spread from the mean. This line is the mean, 10 and 10 here. Whereas in the first data set, it's pretty closer to the average mean of 10 and it's not that spread. That's what it means. And that's kind of the example he's giving. So that indicates that if you ask which one has a better spread or which one has a more variance, because we're talking about a measure of variability, it's very clear. Since the mean average deviation of second data set is 3 is greater than 1.5, so it means that the second data set, this one, is more variable or has a bigger spread than the first data set. Because if you go by mean, both of them have 10, that will not work, and hence we go by this method of calculating MAD or mean absolute deviation, and whichever number is greater, we kind of infer or conclude that that particular data set has a more spread or a more variation or is more distributed as compared to the other set. That's kind of the example I wanted to highlight. You can read through that. And the second link that I've referred to is Maths is Fun. And here they have applied to a more practical exam of dogs and their heights. So that way it will be easier to relate that which dog is bigger and which dog is smaller. In that case, they compare the mean value, the height of each of the dog from the average height. That shows which dog is way too tall and which dog is way too small. That's another way of looking at that. This kind of examples help you understand why do we need to calculate that, why not just a regular mean versus why need to calculate a mean absolute deviation. And hence I put these links. From an exam standpoint of view, again, not required, but if you want extra reading and just wanted to get a perspective of what we're talking about, these are the 2 links which will give you additional information, particularly these examples that I'm talking about. So with that, I'll wrap up the concept of mean deviation. Hopefully it was helpful. The big takeaway is this whole table. That's what we will plot in the examination problems also. In the next two episodes or next episode, I'm going to solve some examination problems, and this is the table that I'll be using kind of to plot that. I'll see you in the next episode.